myself Ritu Singh from Lakshmi Institute of Technology, Saregaon. As in the early chapter, I have went through calculation of mixed design. One problem was there, and in this I will continue from the step 4. I will continue as I have calculated the cement content, and from the next course aggregate fine aggregate I will continue in this lecture. Okay. So we have seen the problem in the last lecture that this is data given over here, grade and this characteristic strength, exposure, this target mixed target slump, size of coarse aggregate, fine aggregate belongs to zone 3, and specific gravity of all the gradients. Okay, water absorption of coarse aggregate and fine aggregate. Okay, so directly I will go to the step 5, that is calculation of volume of coarse and fine aggregate content. Okay, so it will become interesting to you as I have solved till here. I have solved calculation of cement content as 404. Actual cement content we got as 404 kg per meter cube, which is greater than 300 kg per meter cube according to our moderate exposure. Okay, so now it is remaining is coarse aggregate and fine aggregate. So volume of coarse aggregate we got at 0.64. From where we got? We got from this IS Indian Standard 10262/2009. Table 3 it is mentioned as we have 20 mm size of coarse aggregate and your fine aggregate belongs to zone 3. So according to this table, and if your water cement ratio is 0.5, so according to this table you will get your coarse aggregate as 0.64. Okay, now we have some editing over here for the actual coarse aggregate. So as per the rules given in the Indian Standard 10262/2009, page 3, clause 4.4.1, for every increase or decrease by 0.05 in water cement ratio, the above value will be decreased or increased by 0.01 respectively. So these things you need to understand. Okay. Here your water cement ratio is 0.5, but I have actual water cement actual water cement ratio as 0.45. Okay. So here it is said that if you are increasing the water cement ratio, your coarse aggregate will decrease. It is inversely proportional. So will decrease by 0.01 by 1%. So if you are increasing your water content by 5%, your coarse aggregate will decrease by 1%. And if you are decreasing your water content by 0.5%, your coarse aggregate will increase. So inversely proportional. Okay, you understood? So here what we will do, we will design according to our this data given here. So what we will do, we have already have 0.64 here. So we have here it is decreasing by 5%. You can see water cement ratio, it is decreasing by 5%. So it is 0.45. So what we will have? We will increase here as coarse aggregate, we will increase by 0.01, that is 1%. So here final coarse aggregate we will get as 0.65. I think you understood according to this. Okay. Now what he has said, another rules, that if the placement of concrete is done by pump or where it is required to be worked around congested reinforcing steel, it is desirable to reduce the estimated coarse aggregate content determined as above up to 10%. So you understood? If you are using your pump, means it is pumpable concrete if you are using, then you have to decrease your water content by coarse aggregate by 10%. So what you will do? You will decrease this 10% of this coarse aggregate you got as 0.65. Understood? So, here you will get 0.65, you can calculate 10% decrement you are doing. So, minus sign into 0.65. So, you will get 0.585 as volume of coarse aggregate. So, this is the volume of coarse aggregate. Understood? Now, volume of fine aggregate you have to find. So, you know this fine aggregate plus coarse aggregate equal to 1. So, you can calculate your fine aggregate over here. You got coarse aggregate as 0.585 equal to 1. So, fine aggregate 1 minus this thing 0.585. So, you will get 0.415 as your fine aggregate. Okay. So, these things you understood? Okay, let us move forward. Now, last step is we have to design our mix calculation with reference to this IS 10262/2009. Okay. So, we have to design our every ingredients of concrete based on volume of concrete. So, our volume of concrete is 1 meter cube. So, based on this we have to take the volume of each ingredients. So, what is your volume of cement? So, your volume of cement will be the mass of cement by specific gravity of the cement. So, what is your mass of cement? As I have calculated earlier, your mass of cement is 404 here, 404 I have calculated earlier. Okay, 404. Your specific gravity of cement you have in the question here, you can see specific gravity of cement 2.93. Okay, so 2.93, okay, into 1000. So, here you will get the mass of in meter cube, you will get volume of cement. So, it is nothing but 0.138 meter cube, your cement value. Now, next is volume of water, same formula. So, volume of water, what you have volume of water? It is 181 liter. If you do not remember, you can go reverse and see the amount. So, 181 liter by 1, specific gravity of water is 1 into 1000. So, here you will get 0.182 meter cube as the volume of water. Third is volume of admixture. This is very important. So, same formula I will do, mass of admixture by specific gravity of admixture. So, whatever admixture you are adding, so admixture is designed by this manufacturing company. So, this in the bottle it says written is specific gravity and the amount you should take in the 1 bag of cement or 100 kg of cement. These things should be written there. Okay. So, here what we have assumed, we have assumed that we will take 1.2% as the mass of these things admixture. Okay. So, we can calculate, and we have in the question or it is written over here the specific gravity of admixture as 1.121. So, we can calculate mass 1.2%. So, percent by 100 we can calculate into your cement content. So, 404 your cement content by 1.121 specific gravity into 1000. Okay. So, we can get as 0.004 meter cube as your volume of admixture. Okay. Now, these things are also important, volume of entrapped air. So, you know that the amount of voids we are counting in the this as a volume of voids as an entrapped air in the concrete. But in the IS 10262/2009 it is not mentioned, but practically we should take this as 2% of coarse aggregate as volume of entrapped air. So, here we will calculate the this volume also. So, 2 by 100 we will get 0.02 meter cube as an entrapped air. So, this volume of all aggregate we will get as coarse aggregate or fine aggregate. How we will get? We will volume of this concrete. Concrete, you know the volume of concrete as 1 minus volume of every ingredients like volume of cement plus volume of water plus volume of admixture, okay, plus volume of entrapped air. If we will minus from volume of concrete, we will get the volume of coarse and fine, okay. So, as volume we are getting volume of coarse and fine as 0.656 meter cube, okay. Now, here it's need to, for the proportion of trial mix, it need to mention, calculate the mass of coarse aggregate and fine aggregate individually. So, how will calculate the coarse of fine aggregate, coarse aggregate? That is, here I will show you this volume of all aggregate into your volume of coarse aggregate. Okay, volume of coarse aggregate I got from here by calculation, okay, into your specific gravity of coarse aggregate into 1000, you will get the mass of aggregate in kg. So, here through calculation you can calculate, here through calculation I got as 1082.2 kg. As you know that your volume of all aggregate is 0.656 and your volume of coarse aggregate individually I calculated before, that is nothing but 0.585, understood? Your specific gravity is 2.82. So, you will get your coarse aggregate, mass of coarse aggregate as 1082.2 kg. Now, see for fine aggregate I will calculate. So, the volume of here, just I will replace your this volume of coarse aggregate by fine aggregate, okay. So, your volume of fine aggregate, you know, it is 0.415. So, you will get as total answer as mass of fine aggregate is 721.4 kg. I think you understood, okay. So, here I will calculate the proportion of trial mix total. So, I got each and every ingredients in kg per meter cube, in a meter cube. So, I will calculate the proportion of each and everything, that is cement, water, fine aggregate, coarse aggregate, and mixture and water cement ratio, okay. So, how much I will get? Cement, it is 404, it is in kg per meter cube. Water, how much you got? It is 181.82. Fine aggregate 721.4 kg per meter cube. Coarse aggregate 1082.2 kg per meter cube, and mixture 4.848, and water cement ratio 0.45. So, each and everything I got for this M35. So, this is the mixed design for M35 based on Indian standard mixed design. Thank you. Hope you understand. Thank you.